There's nobody in this industry that's doing what we're doing.
A human genome for $1,000 on a simple benchtop device that any lab can afford.
This means sequencing for all.
That's huge. It allows genetics to really come of age.
It's the democratization of human genome sequencing. In early 2011, Torrent introduced the world's first scalable benchtop sequencer, the Ion Personal Genome Machine. It reset the bar on speed, scalability, and simplicity. With these attributes, it quickly became the fastest-selling sequencer in the world, the perfect tool to analyze sets of genes, small genomes, or gene expression. Now at Torrent, we're leveraging decades of semiconductor technology and computing advances, as well as the same simple pH sensing chemistry of the personal genome machine. This is going to allow us to do the $1,000 genome, which has been the holy grail for the past decade, and allow us to do it in just a few hours on a benchtop device anybody can afford.
Our biggest challenge in sequencing the human genome was getting all the data off of one chip. Our first chip, the 314, held over 1 million wells. The Proton 2 is designed to hold over 500 million wells.
The Proton works really at the core by semiconductor sequencing. And the beauty of semiconductor sequencing is it's really as simple as a CMOS chip. You know, every teenager who has a smartphone or camera phone, you've got a little CMOS chip, and that chip has thousands of pixels that measure the intensity of light coming in to generate a photo. But instead of a sensor for light, it's a sensor for chemistry. And it's really this first sort of crossing the divide of chemical to digital information.
The beautiful thing about what we're doing is that all the biology happens right on the chip. In essence, the chip is the machine. All the work happens right on the chip.
And through that, we're able to actually do sequencing, and we're able to do it fast, we're able to do it cheap.
The Proton 2 will sequence a much larger genome, thousands of times more DNA in a few hours. That's the power of semiconductor sequencing.
One of the big challenges going from the PGM platform to the Proton platform was just dealing with a 1,000-fold increase in data. So we've been able to do that by leveraging the latest generation hardware from Intel and others. We're using more cores packed into the instrument itself. We've moved more processing off the instrument and onto the Ion chip itself. And we're leveraging the latest in hardware coprocessors to make sure that we're able to quickly process that data and distill it into just the most relevant biological information. All of those things together combine to create a $1,000 genome in less than a day on a simple benchtop sequencer.
The first complete human genome cost us $3 billion to sequence. What's amazing is that just a decade later, on the Ion Proton sequencer, we're going to do it for $1,000. The Proton sequencer opens up entirely new vistas for the scientific community.